Compressing and archiving. Hackers often need to download and install new softwares, as well as send and download multiple scripts and large files. These tasks are easier if these files are compressed and combined into a single file. If you come from the Windows world, you probably recognize the concept from the zip format, so which combines and compresses files to make them smaller for transferring over the internet or removable media. So there are many ways to do this in Linux, and we look at few of the most common tools for doing so in this lecture. So we'll also look at the ddelete command, which allows you to copy entire drives, including deleted files, onto those drivers, actual drives, not drivers. So what is compression? So the interesting subject of compression could fill an entire course by itself. But for this course, we only need a rudimentary understanding of the process. Compression, as the name implies, makes data smaller, thereby requiring less storage capacity and making the data easier to transmit. For your purposes as beginning hacker, it will suffice to categorize compression as either loosey or looseless. So loosey compression is very effective in reducing the size of files, but the integrity of the information is lost. So in other words, the file after compression is not exactly the same as the original. So this type of compressions works great for graphics, video, and audio files, where a small difference in the files hardly noticeable, like MP3, MP4, and PNG and GPH are also all lossy compression algorithms. So if a pixel in a PNG file or a single note in a MP3 file is changed, your ear is unlikely to notice the difference. Though of course music aficionados will say that they can definitely tell the difference between an MP3 and uncompressed FLAC file. So the strength of lossy compressions are it's efficient and effectiveness, but the compression ratio is very high, meaning that the resulting file is significantly smaller than the original. However, lossy compressions is unacceptable when you are sending files or software and data integrity is circular. For example, if you are sending a script or document, the integrity of the original file must be retained when it is decompressed. So this lecture focuses on the lossless type of compression, which is available for a number of utilities and algorithms. Unfortunately, lossless compression is not as efficient as lossy compression, as you might imagine, but for the hacker, integrity is often far more important than the compression ratio. Tearing files together. So usually the first thing you do when compressing files is to combine them into an archive. In most cases, when archiving files, you will use the tar command here. So let's open here. So you will use tar command. So tar stands tar here. So tar stands tape archive here. So a reference to the prehistoric days of computing when systems used tape to store data, this means tar here. So the tar command creates a single file from many files, which is then referred to as an archive, tar file, or tarball. For instance, you say you had 3 scripts files like the here, for example, touch here, touch here, for example, tech beans 1.c hash here, touch tech beans 2.python here, tech actually touch tech beans 3 dot here, for example, out here. As you can see, we created files, but they are empty files. So if you navigate the directory that holds them and perform the long listing, you can clearly see the files and details you'd expect, so including the size of the files here, as you can see here. ls la here, actually ls l is okay here. So as you can see, we created 3 files. Let's actually copy them to folder here, and let's change it with our text editor. Actually, let's example proj here, and let's copy these all here, and here let's open here and put them put inside them something here, just an example ch file here. Here, as you can see, we created a lot of it here, and let's open this as well. Python file here, as you can see here, and let's open here and just that out file sometimes uses for C compiled C scripts here, or programs here. Yeah, let's as you can see here, we have a new example profile here. So cd example here and lsl here. As you can see here, there's a different files. So let's say you want to send all 3 of these files to another hacker you are working with on a project. So you can combine them and create a single archive file using tar command here, tar cvf. So we are entering the name of our file here, techbeans project.tar here, and we are assigning our files here without comma here. So first file here, techbeans1ch, techbeans3 out here, and techbeans2 python here. Oops. As you can see here, we compiled we create a tar file. So let's break down this command to better understanding. So the archiving command is a tar, and we are using it here with 3 options, as you can see here. So the C option here means create. V here which stands for variables, and it's optional. You can it's not mandatory here. So it's for outputting these files, which files is created in tar files. And F command here means write the following file here. So the last option will also work for reading from files. Then we give the new archive the file name you want to create from 3 scripts here. As you can see here, we named it the techbeans project here, tar. Of course, in full, this command will take all 3 files here and create a single file. So here techbeans project tar out of them. So when you do another long listing of the directory, you will see that it also contains a new tar file here, as you can see here. So note the size of the tar file is here 399360 here. So when the 3 files are archived, tar uses significant overhead to perform this operation, whereas the sum of 3 files before archiving here, let's calculate it here. So we will calculate these 3 files here. Let's see it. the first TechBeans one C hash here plus 31863 here plus lastly is our route file 357304. As you can see here, our type file is 393946 here. So, but in here 399,360. So this tarball here actually. So this is greater than. So this is greater than our total of sum of these files. So in other words, the archiving process has added almost let's minus here or here minus 399360 here. So as you can see here, the tar process is added almost 5414 bytes to it. So although this overhead can be significant with small files, it becomes less and less significant with larger and larger files. So we can display those files from the tarball without extracting them by using the tar command within the tcontent list switch here, tar tvf here and TechBeans project here. Actually, let's see how many minutes we have. Yes. So can you see it actually? Yes. So here we see our 3 original files and their original sizes. So you can then extract those files from the tarball using tar command within the X, which is extract switch as shown here. For example, tar xvf here, xvf here. Let's first ls la here. So now tar for comprehending these files here, xvf here, and TechBeans project. As you can see, we extracted these files here. So we extracted these files. So let's delete these files here, and I will see how to extract it here. As you can see here, we extracted these files from TechBeans project.tar file here, as you can see here. So here, because you are still using the V switch, this command will show which files are being extracted in the output here. If you want to extract the files and to do so slightly, meaning without showing any output, you can simply remove these V, which is verbose command switch here. So here xf and nothing output, but our files still extracted. So the files have been extracted into the current directory. You can do a long listing on the directory to double check. So note that by default, if an extracted file already exists, tar will remove the existing file and replace it with the extracted file here. So in later lecture, I will show you compressing the file. So I'm waiting you in later lecture. Now we have one archived file, but the file is bigger than the sum of the original files. So what if you want to compress those files for ease of transport? So Linux has several commands capable of creating compressed files. So we will look at these here, gzip, which uses the extension tar here. Actually, gzip here, gzip uses extension tar gz or tgz here like that. So we have bzip2 here, bzip2 here, which uses extension tar bz2 here. Actually bz is not separate, and we have compress here, and this is that uses the tar z here like that. So these all are capable of compressing our files, but they use different compression algorithms and have different compression ratios. So therefore, we will look at each one and what it's capable of. In general, compress is the fastest. Compress is the fastest, but the resultant files are larger. So bzip2 here is the slowest, but the resultant files are the smallest. And gzip falls somewhere in between fast compress and bzip2. The main reason you, as budding hacker, you should know all three methods is that when accessing other tools, you will run into various types of compression. Therefore, this section shows you how to deal with the main methods of compression. So compression with gzip here I will show you. So let's try GNU-zip here first, and as it's the most commonly used compression utility in Linux, so it's popular in Linux. So you can compress our TechBeans project tar file by entering here, for example, let's delete our tar file here. Let's complete new projects here. Gzip here, TechBeans, and one turner operator here. So by entering here, and let's enter, and let ls, and as you can see here, we gzipped it. Actually, so as you can see here, and let's open here. So we have ch file here, and we have actually let's return our TechBeans project tar from trash here, because I will do some example here. So let's unzip it as well here, and TechBeans and TechBeans1 here, and TechBeans, delete this TechBeans here. So we can compress this compressed file too, but it's actually not compressed, it's just tarred, and the file is not reduced here. So we can reduce this file here, for example ls, as you can see. Let's copy it here, cp TechBeans project here, TechBeans project, and TechBeans project here, TechBeans project here, copy, or just like that, copy dot tar here, ls. So we created copy of it. So let's gzip our TechBeans project here, and TechBeans project tar. So as you can see here, TechBeans project tar here, tar gzip. So we copied it. So now lsl here. So as you can see here, our file size is reduced here by significant amount here. So notice that we used before of it, we used wildcard operator here. Let me show you here. So this tells Linux that the command should apply to any file that begins with TechBeans with any file extension. You will use similar notation for the following examples. When we do long listing on the directory, we can use TechBeans tar has been replaced by here TechBeans project tar to TechBeans project tar gz here. We created another file like that, just a copy here. So as you can see, file size is use significant amount, almost. Let's calculate it. 399360 and y2. As you can see here, the file size is sized I actually 178 times. So we can then compress that file by using the gunzip here command. Gunzip, short for GNU unzip command here. Here g unzip here. So g unzip techbeans project tar gz here, and let's do it ls here. So we unzipped here. As you can see, there's a no gz extension of it here, and our file size is returned the same here. So once uncompressed, the file is no longer saved with the tar gz extension, but with the tar extension instead. So also notice that it's returned to its original size here. And try doing a long list to confirm this. It's worth nothing than the gzip can also be used to extract zip files here. So we can compress, as I said earlier, bzip2 here. Another of the other widely used compression utilities in Linux is bzip2, which works similarly to gzip but has better compression ratios, meaning that the resulting file will even be smaller than that here. Actually, we closed our calculator, right? Yes, we closed our calculator and calculator here. So now we will zip these files again here. So bzip2 techbeans project.tar here and ls/la here. As you can see here, it's almost 488 bytes here. So now let's calculate it. 360 and divide by 488 here. As you can see, there is almost 818 times our file is smaller than our original file. So but in previous case it was 100, more than 117 here, 70 here. So when you do a long listing, you can see the bzip has compressed the file just down to so many bytes here. Also note that the file extension is now tar bz2 here. So to uncompress the compressed file, use the b unzip2 and techbeans project tar bz2 here, and let's ls here, and as you can see here, our file size is here. So we can use the compress command as well. I want to show you lastly here. So the compressed finally you can use the compressed to compress the file here. This is probably the least commonly used compression utility, but it's easy to remember. To use it, simply enter the compress followed by the file name, for example techbeans project .tar here, and let's lsl here, and as you can see, it's not much of compression here. As I said earlier, 399360 divided by 12,491 here, and as you can see, it's smaller than just 31 times here. So note that the compression utility reduce size of file here. Also note that the file extension now is tar z here with uppercase z. So to decompress the same file, just press you just use uncompressed here, uncompress here, and your file name techbeans project.z here, and lsl here. So you can also use the GNU unzip command with files that have been compressed with compress command here. Just keep in mind. So we can create a bit by bit or physical copies of the storage devices as well here. just within the world of information security and hacking, one Linux archiving command stands above the rest in its usefulness. So the dd command makes a bit-by-bit copy of a file system, or even an entire hard drive here. So this means that even deleted files are copied. Yes, it's important to know that your deleted files may be recoverable here, making for easy discovery and recovery here. So deleted files will not be copied with the most logical copying utility, such as the CP here. And once a hacker has owned a target system, the dd command will allow them to copy the entire hard drive or a storage device to their system. So in addition, those people whose job is to catch hackers, namely forensic investigators, will likely use this command to make a physical copy of the hard drive with deleted files and other artifacts that might be useful for finding evidence against the hacker. It's critical to note that the dd command shall not be used for typical day-to-day copying of files and storage devices because it's very slow here. Other commands to do the job faster and more efficiently. So it is truly excellent when you need a copy of a storage device without file system or other logical structures, such as in a forensic investigation here. So dd-if is the input file here, input file here, and off is the output file. So if you wanted to make the physical copy of your flash drive, assuming your flash drive is STB here, and then input file is gonna be dev STB. This is your flash drive, and output file is the file which you want to copy bit by bit your flash drive here. In this case, for example, it will be home here, Kali, and our flash copy secret here. And let's break down this command here. So dd, your physical copy command. So if designates your input file, and with dev STB is representing your flash drive in div category directory, and off here designates your output file, and here home Kali flash copy secret here is the name of the file you want to copy the physical copy to. For more complex explanation of the Linux system design item of drives, it will be discussed in later lectures here. So Linux has a number of commands to enable you to combine and compress your files for easier transfer. So for combining files, tar is the command of choice, and you have at least 3 utilities for compressing files. These are gzip, bzip2, and compress. So all with different compression ratios. So the dd command goes above and beyond. It enables you to make a physical copy of storage devices without a logical structure such as a file system here, allowing you to recover such artifacts as deleted files.